Assalamualaikum warahmatullahi wabarakatuh. So we continue with a second example on translation. Basically, in your textbook, there are two more example for uh, rectilinear motion. Example 17.6 on page 416 and example 17.7 page 417. So you can do it by yourself, but this example is about curvilinear motion. Uh, Okay, so we have a 100 kilogram beam supported by two rods having negligible mass. So that this negligible mass like a ropes. Determine the force created in each rod. So force created by uh, in each rod if the is at the instant theta is 30 degree. Theta here is 30 degree and omega. The swing. The omega. The angular velocity is 6 radian second. Okay, so class, try to imagine that you have a road here, uh, and then this is G, and then this is swing to the left. So what happened? You can draw it like this. Sorry, so you cannot, impossible to be like that lah. Sorry. And this is C. Alright, so it swing like this. So means that G is something like this. The motion of G is something like this. G, this one is G prime. Alright. Similar to the edge of this one, it swing with the same path, same path. Okay, so this bar or this beam doesn't rotate. It experience a curvilinear motion. Right, you can have a two rod. You hang a beam or rod by two strings. Try to swing the rod. You can see what's how does it move. All right. So we go to the next page better. Okay. So what you can do is you can draw what? You can draw free body diagram and kinetic diagram. FBD. You have the rod. You have W downwards, and you have what? Tension. Because you have to find the tension or forces. You have to find forces. Created in each rod means that I put it as a tension. T. Okay. Alright. And I also have another T tension due to cable C. For example, C, I denote it as a C. Alright. So here is the mass is 100 kilograms. So the W is 981 Newton. Okay. So now it X. This is your and then your kinetic diagram. If you have a kinetic diagram, so this one A, point A, some point C, right? So basically A is referred to G, right? But for this case, any point lay on this rod or beam experience the same path. And so if this one swing like this, so this point as well, for the example, also swing like this. So any point swing on the same path, same vector. Okay, so you can say that looks like the radius of the point of rotation for G is somewhere here. Uh, G. Okay, okay. If you can find the acceleration here, you can find if you find any acceleration on this point, it represents the acceleration for each point. Eh? For the example, if you can find the acceleration at here, AC, for the example, is equal to AG. It gives you the same value. Eh? So for the FB, kinetic diagram, you can say that instead of find this, because this is a curvilinear motion. This one AN. This one is AC. Had AN. It is the same if you find AT here and AN here. Similar, even for AA as well. AN, AT, AN. If you can find AT, AN here, the answer is similar for this one as well. AT and AN at G, AT and AN at C. Yeah, so you can. This is the kinetic diagram. So we start with the summation of force. Eh? So we can draw the X, Y. So if you want to choose X and Y, is difficult. It's easy if you choose uh, the normal and tangential coordinates. The summation of force in, for example, in normal coordinate. Normal is like this, like this. So we choose like this, draw a spiral line, is positive. Goes up like this, is positive. Is equal to M A G N. Okay, you can see that it give you right. Okay, just I want to repair something. This is a A. I was just change something. This one B, B, sorry, B. This one D, D. Okay. Similar to the figures, actual figures. So AN. Okay, so upward is positive. So TA, they put TA here, or in the books they put TB. It doesn't matter lah. Let's say I take a TA plus TC, because TC has the same direction of TA. Okay, but the thing is N, sorry, weight. Weight here, weight should be like this lah. Let me erase the wrong one. Alright, here W, W, you have to split into two component as well, normal and tangential. So how to do that? If I can change the in color first. So it has two component, in N and in T. So in N is downward lah, so it will give you negative values. Negative. So negative W. So angle here is 30. 30. So angle here is also 30 lah. So W cos 30. And then it's equal to mass 100 kilograms times A AGN. What is the value of AGN? AGN. AGN, if you learn in previous uh, uh, particles, in a particle, AN, just refresh our knowledge on it. So AN is basically is given by, you remember, AN R, AN is equal, AN is omega square rho. What is omega? Omega is angular velocity. Rho is the radius of curvilinear path. Okay, so what is AT? AT is basically rho alpha. Okay, so rho is the radius, alpha is angular acceleration. So here you got omega. What is omega? Omega is given as 6 radian per second square. Okay, because omega square times rho. Rho is the radius, because this is the axis of rotation. So the radius is 0.5. So you have two equation here. Sorry, you got the equation here. I can put this as 1 0 uh, 180 180. So this is the first equation. I change to on the color green. So tangential component, and they say in this direction is positive. Summation of force in tangential component is equal to MAGT. Alright. So do we have the tangential component for TA? No. Because TA is 0. Eh? In tangential component, because the tension is only in a normal component. Normal component. So what do we have? We have only W in tangential component, which is positive direction. Positive direction. So it will give you W sine 30 is equal to what? M is mass, 100 times rho. Rho is what? Rho is 0.5. Okay, 0.5. And alpha is unknown. As alpha is unknown. Or you can remake it as a AGT. AGT. Doesn't matter. It doesn't matter. Because once you got alpha, you can calculate what is the AG. Okay. So do you think that we can solve this one by uh these two equation? Let's check. Let's check it. You have what's unknown here? What's the unknown here? 1, 2. W is known. So if we know this one, W we know. What else? So we don't have this one. So we have three unknowns, TA, TC, and alpha, and we only have two equations. So we still need one or more equation so that we can solve this problem. Okay. So you go back to this summation of moment. Summation of moment. Let's say that you choose the moment at point G, and it's equal to alpha G. Just write the basic equation alpha. As we mentioned, this one is curvilinear motion, not a rotational motion, so that alpha is 0. So the summation of moment at G is 0. You have simplified your equation. So let's choose that the moment in counterclockwise is positive. All right. So we have what just now? We have a sorry wn wt sorry wn in normal. Oh, sorry. Okay, we have ta here. I put ta here, and then I have tc here, right? So when you are referring to point G, so these two forces or weight doesn't counted lah. Do not counted lah. And then you will have only two, TA and TC. So TA, eh, TA, um, TA. Okay, next, since it create a clockwise, TA cos 30 degrees, yeah, times the R which is from the distance from B to G, right? So it will give you 0.4. TA cos 30 is TA in this direction or Y, and then you have another component TA in X. This one TA in Y. Since TA in X cross G, so this one is not counted. Similar to C, you have sorry. So you will have TCY and TCX. TCX is not counted lah because it cross the point G. Eh? So this one is positive lah because this one TX TCY is positive since it create a counterclockwise moment plus TC cos 30 degrees times times 0.4 and then is equal to 0. We can see that TA cos 30 degree times 0.4 is equal to TC cos 30 degrees times 0.4. So we can see that TA is equal to TC. You got the third equation here. So TA is equal to TC. So if you go back to this one, first and second equation, TA is equal to TC. So TA plus since TA is equal to TC, we can change either one lah. We remain the TA, replace TC by TA. Replace TC by TA minus omega. W. Sorry, TA plus TC. TA plus TA minus 981 W cos 30 is equal to 100 times 100 times 100 times 18, which is 1800. 1800. Alright, 18 equal to 1800. Okay, the second equation, W or 9, let's say W sine 30 is equal to 100 times what? 0.5 times alpha. Right? So how many unknown you have? You have only two, correct? So you can simplify this one. 2TA minus 981 equal to 1800. Here 981 times sine 30 is equal to 100 times 0.5 times alpha. So you can get the answers here, which is TA is equal to 1.32 kilonewton, and alpha alpha is alpha is and alpha is 9.81 eh? uh, radian per second square. Since in the in the problem you need to find A, so A is R or rho alpha, which is 0.5 times 9.81 is 4.905 meter second square. So that's the answer for this problem. Okay, so thank you very much for watching. And then one thing before I left, you can choose the summation of moment, not at point G, but you can choose at point B as well, or the summation of moment at point D. Okay, even you can try to find the summation of moment, the summation of moment, but it will be complex. Summation of moment at point A for the example, or summation of moment at point C. You can try to practice, not to solve the problem in your exam, but to practice. You can prove that if you choose any point to find the moment, so it will give you the same answers. All right, thank you very much for watching. Thank you.